Assalamualaikum warahmatullahi wabarakatuh. We are group 2. My name is Norma Izzatul Husna binti Zulkifli. My other group members are Nurul Nadia binti Mak Jusof, Nur Shazana binti Ma'aruf, Nurul Iza binti Zulkifli, and the last one is Sahsi Kalagodendam. We are presenting about measurement groundwater flow method. For the introduction, groundwater is a term used in hydrology to describe the science of occurrence, distribution, and movement of water under Earth's surface. Groundwater flow from higher hydraulic head areas to lower hydraulic head areas. The physical qualities of the framework in which the groundwater system occur and flow are referred to topography and geology as a preliminary examination of the occurrence of the groundwater system. Two key hydraulic parameters are porosity and hydraulic conductivity. This report provides an overview of the method that currently applied and described in a literature of importance of groundwater monitoring. Consideration for choosing appropriate method based on Darcys Law.
Ms. Nurul Nadia binti Majuso and my matrix number is AF200097. Okay, so this is the importance of groundwater monitoring. Groundwater monitoring can be used to monitor variations in groundwater levels to aid decision makers in determining the long-term viability of an aquifer as a source of water and making appropriate policy decisions. After that, it provides groundwater contamination information such as pollutant identification and contaminant level measurements and assists in the identification of groundwater contamination sources. And then, groundwater levels must be managed to avoid harm from saltwater drought or flooding. And lastly, evaluate the effects of climate change on groundwater levels, allowing decision makers to issue timely drought warnings or declarations and implement appropriate mitigating measures. Okay, so this is the field measurement device. The first one is PVC well screen. The second one, water level measurement device, or we call as e-tape, for use in wells. And lastly, logging pressure transducers.
Assalamualaikum, my name is Nur Shazana binti Maruf and my matrix number is AF200065. So next, for Darcys Law. Darcys Law generally corresponds to the methods used to study groundwater movement in terrestrial aquifers. They typically require measurements of the component of the Darcy equation, which is Q equal to negative K dH over dL. Next is hydraulic conductivity. In this topic, there are a lot of tests, but today I'm going to present grain size analysis and pumping tests. So for grain size analysis, from the grain size distribution of a sediment sample, an estimate of hydraulic conductivity can be derived employing empirical relations between hydraulic conductivity and some statistical grain size parameters such as geometric mean, median, effective diameter. For pumping test, a pumping test to determine hydraulic conductivity requires the existence of a pumping well and at least one observation well piezometer in the capture zone. The well is pumped at a constant rate and drawdown in the piezometer is measured as a function of time. Next, porosity. The porosity of a sediment sample can be determined by relating the bulk mass density of the sample to the particle mass density. The bulk mass density is the oven-dried mass divided by the filled volume of the sample. The particle mass density is the oven-dried mass divided by the volume of the solid particles, which can be determined by a water displacement test. Lastly is groundwater velocity. Groundwater velocity may be estimated by introducing a conservative tracer, example a dye such as uranium, or a salt such as calcium chloride. to a well and recording the travel time for the tracer to arrive at a downstream observation well. The groundwater velocity can then be computed from the travel time and distance data. Because groundwater velocities are usually small, the wells need to be close together in order to obtain results in a reasonable time span. Thus, only a small portion of the flow field can be observed by this method.
Hydraulic gradient. Hydraulic gradient, the equipment is simple and quick to install, put in, and also the measurement analysis and the procedure is open. This method is appropriate for tiny scale application and allow an in-depth details analysis of flow condition in the subsurface. In case of horizontal flow, the hydraulic gradient can be calculated from the difference in hydraulic head and the horizontal distance. For the vertical components of groundwater flow, which are particularly important to understand the interaction between groundwater and surface water, a piezometer nest may be installed with two or more piezometers set in the same location at the different depths. The hydraulic gradient can then be calculated from the difference in hydraulic head and the vertical distance. Environmental tracer method. These tracers separately or in conjunction may suggest a unique solution in detailing the hydrogeochemical process operating. Environmental tracer in groundwater system can give information both on current and past flow conditions independently of hydraulic analysis and groundwater modeling. Environmental tracer method because the combination of exhausted tracer and hydrological data yields the most reliable result, and it is an up-to-date research along with best practice, while the hydrograph separation is a natural tracer.
For conclusion, groundwater is generally moving from higher to lower hydraulic head, and the slope of the head surface are known as potentiometric surface of an aquifer. The total head at each location on this surface is determined using components of the Bernoulli equation, where the velocity head term was shown to be negligible. The quantity of groundwater moving through a defined cross-sectional area is solved using applications of Darcys Law that can be performed by constructing flow nets. Recharge areas are defined where the flow lines diverge from a given area and flow lines converge in groundwater discharge area. There are a lot of reasons groundwater flow systems are poorly understood. The misinterpretation of level measurement was suggested as a key factor. Ignoring vertical flow, combining shallow and deeply completed wells, and combining with short and long well screens contribute to the difficulty of interpreting level measurement data. Care must be taken to make sure the level measurement data are known as aquifers. Mixing level measurement data from different aquifers lead to misinterpretations of groundwater flow and may cause a host of problems. That's all from us. Thank you.